The main idea in this video I want to discuss is limits, but we are going to play around in Desmos a little bit and try to gain some intuition for the complex function z squared. It's kind of hard to visualize complex functions in their entirety, right? Given that, well, it requires 4 dimensions. Some people work around this with color. But okay, so limits when you're only dealing with real functions, right? You only have to approach from two places, the left and the right, right? As long as the limit from the left and the limit from the right meet, you're good, and you can say the limit exists. However, it's different in the complex plane, right? The complex plane, well, that's just you're not dealing with one-dimensional numbers, you're dealing with two-dimensional numbers. So it's not enough just to approach from the left and the right. You have to approach from the top and the bottom and, well, everywhere in between. And not just in any direction, but in any way, right? Are you approaching along a straight line? Are you approaching along a parabola? Are you approaching along a sine wave? All right, and so we're going to explore that in this video. So here in this first graph right here, I have this straight line and the unit circle that goes around it, and that's going to be our pre-image. Now, if I take all the points along this circle, and again, Desmos doesn't have a complex setting, but we're treating these as a complex plane here. So right here, this would be 2 plus 2i, and if I square that, I will get 8i. And so if I square everything along this circle, I will get this path here. This would be the image. And if I square all the points along this straight line, I will get this parabolic curve. Right? And so because we are dealing with z squared, we should expect this to have some parabolic nature to it. And we'll see that here. Actually, let's make this a little bit bigger so I can see more of this curve. And if I move this line from left to right, we can see that the image does trace a parabolic curve. All right, good. So this is believable that this is a part of the graph of z squared in the complex plane. And let's go and let's center this around 2 plus 2i like it was before, where we had it before. Now, we can already see here that as I approach 2 plus 2i from either the left or the right, this parabolic curve here will approach 8i. But again, it's not enough just to look from the left and the right. We have to look from all possible directions. And so as I spin this line right here, we will see that the parabolic curve will also spin around 8i. So no matter which direction I approach 2 plus 2i from, the corresponding image will approach 8i from all possible directions as well. Another way to view this limit is to constrain those the circle here. I guess you could call it a set. But yeah, so here C controls that. Here as I make C smaller, we'll see that the pre-image circle will close in on 2 plus 2i, and the corresponding image curve will close in on 8i. And it will do this infinitely small as you want to go. And then even as we've done this, we'll see that it approaches from any possible direction. Okay, good. So at least right now we're certain that the limit as z approaches 2 plus 2i of z squared is 8i along any line. Now there are other types of curves we could approach from. So we'll look here. Let's approach along a cosine wave. Now, we'll get to the limit here in a little bit, but I just want to look at this graph. So here, this cosine wave, that's your pre-image, and if I take all the points along there, all the a plus bi's, and I square them, I will get this curve right here. Now, let's make this longer so we can see the entirety of it. All right, good. So yeah, I take that cosine wave and I square it and I'll get this path. We can go ahead and open that up a little bit. This is where it gets kind of cool. is even though now I'm dealing with a cosine wave instead of a straight line, we can still see the parabolic nature, right? This does oscillate, however, but it does so in along a parabolic trajectory. We can make B right here will control the amplitude, so I can make the amplitude of the cosine wave 0, which goes back to a straight line, and then or I can increase the amplitude and get this curve. Put that back down here, and then I can extend. I can change the period of the cosine wave, which will change the length of the image here. But good, so we still see we get that parabolic nature even though we're dealing with a different curve. And let's go ahead and center this around 2 plus 2i again. And let's go ahead and bring back, let's make this smaller. Okay, here we go. So, again, we can see that as we approach 2 plus 2i along a cosine wave, along the path of a cosine wave, the image will approach 8i. So as we approach 2 plus 2i, the image will approach 8i. And it doesn't matter, right, that we could change the period here. We can make the period longer. Unfortunately here I don't have a way to rotate it from any possible direction, so we're only looking at one direction here. But again, yeah, as I approach 2 plus 2i, I will approach 8i on that image there. So good. Again, it's hard, rather impossible to visualize all possibilities, right? All directions from all different paths, but we can start to gain in some intuition here about, yeah, no matter how I approach that 2 plus 2i, the image curve will approach 8i.